Hello everyone, myself J. Vignesh Shankar. I am going to talk about topic modeling from natural language processing. Let's get into the presentation. First of all, we have to understand what is data, text data. Text data is all around us, ranging from books and articles to social media posts and customer reviews. The large volume and diversity of text data sources present a challenge and an opportunity. It's a challenge because making sense of this vast amount of information manually can be overwhelming. However, it's also an opportunity because by using automated techniques like topic modeling, we can derive meaningful insights from this data. What is topic modeling? Topic modeling is a collection of text mining techniques that uses statistical and machine learning models to automatically discover hidden abstract topics in a collection of documents. Topic modeling is also an set of unsupervised techniques that's capable of detecting word and phrase patterns within documents and automatically cluster word groups and similar expressions, helping in best representing a set of documents. At its core, topic modeling is a computation technique that aims to uncover the latent or hidden themes within a collection of documents. It's like a sophisticated way of summarizing a large amount of text data. Instead of reading each document individually, topic modeling helps us understand the key topics that these documents are discussing. With the introduction of to topic modeling, there are many cases where humans or machines generate a huge amount of text over time, and it is not prudent or possible to go through the entire text for gaining an understanding of what is important or to come to an opinion of the entire process of generating the data. In such cases, NLP algorithms and in particular topic modeling are useful to extract a summary of the underlying text and discover important context from the text. Objective of topic modeling. The main objective of topic modeling in NLP is to discover topics that are a cluster of words expressed as a combination of strongly related words. Since each topic belongs to one or more documents, one other objective is to in turn express each document as a combination of one or more balanced topics. Motivation for topic modeling. So, why do we need topic modeling? Imagine you are researcher analyzing thousands of research papers, or you are a marketer trying to categorize thousands of customer reviews. The sheer scale of the data makes it nearly impossible to do this manually. This is where topic modeling steps in. It's like having an assistant that can help you organize, categorize, and extract the essence of the information we have. Let's see the curse of dimensionality. The phenomenon of dimensionality states that as we add more features to the model, the amount of data needed to train the model to maintain the same performance increases exponentially. Dimensions are features in the context of natural language processing and machine learning models. This is especially important when training machine learning algorithms, where the accuracy of the model initially increases as the number of features is increased, but starts worsening as the dimensionality is increased, keeping data constant due the cursor of dimensionality. Let's look at the diagram. Curse of dimensionality is especially important in the case of topic modeling based NLP models, as we have a huge number of features owing to a huge corpus of words. Hence, it is necessary to employ feature selection or dimensionality reduction techniques when handling models with huge dimensionality, which we will see further. Let's see how does topic modeling in natural language processing works. When looking at a set of documents, each document can be a combination of multiple opinions or ideas, where words pertaining to that particular opinion are found in different proportions across documents. We can look at the statistics of words in each document and create topics which are clusters of similar words. Topic models help us in discovering potential topics hidden in the entire text of documents as a combination of words with similar meanings and each given document as a combination of topics. Principal component analysis is known as a PCA. It is a statistical technique where the main idea is to reduce the dimensionality of a data set consisting of a large number of interrelated variables, while retaining as much as possible of the variation present in the dataset. Working of PCA algorithm. Transform the columns in the dataset to a new set of variables called the principal components, known as PCs. The main property of principal components or PCs is that they are uncorrelated and can be ordered based on the characteristic values so that we can first view program principal components alone while returning most of the variation present in all of the original variables. So let's look at the diagram for the instance. The colors in the illustration represent the labels of target variables or groups or clusters in the dataset. Axes represent the first two principal components obtained using PCA, nothing but principal component analysis. Let's look at the advantages of PCA. PCA is a versatile and widely used technique for pre-processing in machine learning. PCA helps in speeding up the model training and evaluation time as it reduces the number of input variables considerably. PCA also helps in improving the accuracy of the models in treating the curves of dimensionality and also saves the space needed to store the data with minimal loss, as it also serves the purpose of analyzing the data by visualizing a huge number of dimensions in 2D or 3D space along with their labels. It is widely used in multiple techniques for EDA and post-model explanation. Introduction to clustering. Clustering is an unsupervised machine learning technique for finding subgroups or clustering clusters in a dataset. Central idea in clustering. The partition the observations in the dataset into different distinct groups such that observations within each group are quite similar to each other and those in different groups are quite different from each other. We need to select suitable criteria for defining the similarity between observations, and there are multiple techniques available for cluster analysis. It is an example diagram for clustering where different data are clustered together in a single basket. Like it's categorized into separate ones. Clustering by rows versus columns. We can cluster observations on the basis of the features in order to identify subgroups among the observations. We can also cluster features on the basis of the observations in order to discover subgroups among the columns, like grouping features together. Clustering is used majorly for marketing, for market segmentation, and in some other areas of computer vision. Now we discuss few topics like is topic modeling, clustering, and PCA the same? All three algorithms, topic modeling, clustering, and PCA are unsupervised and used to simplify the dataset with a small number of summaries. The major difference lies in how they are used. LDA topic modeling and PCA both can be used for dimensionality reduction, but LDA provides better accuracies and explainability in terms of text. PCA looks to find a low dimensional representation of the observations that explain a good fraction of the variance. Since output representations are unrelated, they can also be used as input to clustering. Clustering looks to find homogeneous subgroups among the observations by maximizing the distance between clusters. Clusters are not known in advance. Next topic is non-negative matrix factorization. It is known as NMF. It is a technique for decomposing a matrix into two matrices with the property that all three matrices have no negative elements. This is used majorly in recommender systems, signal processing, and bioinformatic fields. The central idea in non-negative matrix factorization is that original input matrix is made of a set of hidden features represented which are essentially interactions between two matrices like users and movies, and the associations are the weights in the input matrix. One advantage of non-negative matrix factorization is that we can find which interactions are potentially gonna happen or rank them, like for use in recommender systems. LDA, latent Dirichlet allocation. Topic model in NLP using LDA discovers topics that are hidden, hence the name latent itself, in a set of text documents by inferring possible topics based on the words in the documents. In LDA, the relationship between each text document and each word, each topic, and words in the corpus are modeled using hidden variables. Each document within the corpus is represented using a Dirichlet distribution over the latent variables topics, and each topic is again represented by another Dirichlet distribution over all the words contained in all the documents. The overall model LTA is based on Bayesian framework with a generative probabilistic model trained on Dirichlet distributions in LDA. With the Bayesian assumption, we can model the topics based on observed data through the use of conditional probabilities on the words. Let's look into the advantages of LDA. Latent Dirichlet allocation is the most popular approach for topic modeling among all other varieties of applications. It has good support and is implemented in a variety of frameworks like Python, R, Java, C, and very easy to deploy. Let's look at the comparison between LD and NMF. Comparing LD and NMF, we find that LDA's probabilistic nature allows for more flexibility in modeling document topic on topic word relationships. On the other hand, NMF's non-negative constraint leads to topics that are often easier to interpret. The choice between the two depends on the specific goals of our analysis. Applications of topic modeling. Let's explore some real-world applications of topic modeling. In the academic world, it helps researchers in organizing and summarizing research papers. Businesses use it to categorize customer feedback, enabling them to identify trends and areas of improvement. Media companies leverage it for content categorization, and even healthcare professionals use it for analyzing patient records. Let's see what are the challenges in topic modeling. While topic modeling is powerful, it's not without its challenges, absolutely. Determining the optimal number of topics is often a subjective decision that can impact the results. Handling noisy data and ensuring topics are meaningful and interpretable are ongoing challenges. It's the future trends of topic modeling in natural language course. Looking ahead, we anticipate exciting trends in topic modeling. The integration of deep learning techniques promises to enhance the accuracy and adaptability of models. Cross-lingual and cross-model topic modeling opens doors to analyzing data from different languages and modalities. Ethical artificial intelligence considerations will remain at the forefront as the field evolves. Thank you.
Our project title is Next Word Prediction, and our team members are Kavya, myself, Nishankar, and Harish. In today's fast-paced digital communication landscape, the efficiency of text input plays a pivotal role in user experience. Whether it's composing an email, crafting a message, or conducting online searches, the speed and accuracy of text entry matter. To enhance this experience, we present a project focused on next word prediction. This project leverages the power of natural language processing and machine learning to predict the next word a user intends to type or speak, making text input faster and more intuitive. By analyzing extensive text data and user-specific patterns, our goal is to create a predictive system that seamlessly integrates into various applications and platforms, ultimately improving user productivity and satisfaction. Let's look into the abstract. Efficient and intuitive text input is crucial to a result. This project explores the development and implementation of a next word prediction system using new natural language processing and machine learning techniques. By analyzing vast text corpora and user-specific data, our system aims to predict the most likely next word a user intends to type or speak, thus accelerating text entry across various devices and applications. We detail the methodology, data sources, and model architectures employed in our project. Additionally, we evaluate the system performance in terms of prediction, accuracy, latency, and user satisfaction. The results showcase the potential for improved text input thus that can benefit users in both productivity and accessibility. Our main objective is to create a predictive text system that can suggest the most likely word or words that would come next in a given sequence or text fragment. This project typically involves natural language processing and machine learning techniques to build a predictive model. Expected outcome. The expected outcome for an expert prediction project includes improved text input efficiency. Users will experience faster, more accurate text entry, reducing typing effort and increasing productivity. Next point is enhanced user experience. The system should provide intuitive and contextually relevant word suggestions, leading to improved user satisfaction. Next point is reduced errors. Fewer typos and spelling mistakes in text input, resulting in higher quality written content. Next point is adaptability. The model should adapt to user-specific language patterns and preferences over time, further enhancing prediction accuracy, compatibility, integration into various devices and applications for seamless and widespread use, data insights, valuable insights into user language behavior and preferences for potential refinements or future applications. Thank you.